Example 13. We're going to write down these functions when we've applied a dilation. So we've got a parabola there, y equals x minus 3, x plus 5. X minus 3, x minus 5, which you should recognize is, concave up, and it's got roots at 3 and 5. So it's going to look a lot like that. And you should also recognize that if you expanded that out, it's going to go through 15. That's terrible. It's going to go through, there we go, 15. So that's my parabola. That's my existing parabola. So I'll change colours and we'll go with question A, horizontal dilation with a factor of -2. So horizontal means it's applying to the x and a factor of -2, which means I'm going to have minus x over 2 minus 3, and then x, I've got to do the same to the other one, so minus x over 2 minus 5 equals y. So I'll just have y equals. So my next line, I want to multiply both of them by 2, so I'm going to end up with 1 over 4 out the front because I'm multiplying it by a half twice. So I end up with, what do I end up with here? X plus 6 and x plus 10. Alrighty. I hope that makes sense to people. That's what we get with the first one. So we've got a quarter. Question B. Oh, actually, I should graph that one now, shouldn't I? So I have -6 and -10 are my ones. And if I multiply that out, I am still, because I'm going to get 60, but it's a quarter, I'm still going to have a intercept of, it's terrible, of 15. So there we go. That's kind of it. All right, next one. So question B. We have a horizontal dilation with a factor of -2. So now what we're doing is we're replacing all the x's this time with x over -half, which is -2x. So we're replacing them all with 2x. So we end up with, with -2x, -2x minus 3, and -2x minus 5. Which we can then get rid of those, and we end up with, so we'll divide all of it by a half, or by a half, so we get 4. So if we divide that out, pull that common factor out, we end up with x plus 1.5, so 3 on 2, and x plus 5 on 2. Okay, so then we've got -3 on 2 and -5 on 2 are our roots. We are still going to be going through 15. All we've done is we are expanding it and contracting or dilating it. We're not actually changing it all that much. So that's kind of what it looks like. Next one, we have a vertical dilation. Give me another color. We have a vertical dilation of -1. Which you should be able to work out is also a reflection in the axis. So we're basically replacing it with -y equals x minus 3, x minus 5, which we could write as y equals minus x minus 3, x minus 5, which you should recognize is just basically going to be exactly the same graph as the one above, but with the negative. And question D, we'll go back to red for now. Which domains and ranges were changed? Basically, all of the domains are all real x. So in part C, is there any range changed? Yes, the only one was part C. So in part C, we went from going, our range changed from y is greater than or equal to, is it -1? Yes. Negative, oh, I hate that. Don't know what does it. -1 to y is less than or equal to -1. And that's the only change out of all those. It's the only change in range or domain.